Hello and welcome to our lesson on chemical symbols and formulae. Let's go. Okay, first up then, looking at this formula, NaCl, can you tell me if it's ionic or covalent? Well, hopefully you would recognise that sodium is a metal. If you hadn't been sure, you could look at your periodic table. It is group 1, it's left of the zigzag line. And hopefully you'd recognise that chlorine is a non-metal. It's right at the zigzag line. And hopefully you would recognise that a compound that has a metal and a non-metal is ionic. So it's an ionic bond holding them together. And sodium chloride is therefore an ionic compound. What about this one? So carbon is a non-metal and oxygen is a non-metal. And a compound made of two non-metals is bonded together with a covalent bond, and therefore carbon monoxide is a covalent compound. All of the compounds in the table in front of you are simple covalent compounds made of non-metals, bonding with other non-metals. I'd like you to pause the video and I would like you to fill in that last column, please. Just jot it down somewhere. How many atoms in each molecule? So hopefully you would recognise that water had 3 atoms in total, 2 hydrogen, 1 oxygen. Hydrochloric acid had 1 hydrogen and 1 chlorine, so 2 in total. Ammonia had 4 in total, 1 nitrogen and 3 hydrogen. Methane had 5 in total, 1 carbon and 4 hydrogen. Sulfur dioxide has 3 in total, 1 sulfur and 2 oxygen. And carbon dioxide, 1 carbon and 2 oxygen. Did you get them right? At this point, it's really worth remembering that some molecules, that is groups of atoms, are bonded together in pairs, and they will naturally go around in pairs, and you would always refer to them in pairs. So if you look at the list in the dark blue box, you would need to know these by heart. Hydrogen is never just H on its own. It might be HCl, part of a compound, but if it's just hydrogen, it would always be H2. Nitrogen would always be N2, and oxygen would always be O2. So diatomic, meaning 2 atoms, di meaning 2. Now, fluorine, bromine, chlorine and iodine are all group 7 elements. So group 7, the halogens, all go around in pairs, and you would always have a little 2 at the end of it. This is going to be really important when you're trying to balance equations. So I want to look at ionic formulae for a minute. This should look very familiar to you. The periodic table, this is the one that you're getting in the exam. This is the one that OCR provides. And hopefully you would recognise those green numbers that I've put up there. Group 1 loses 1 electron. Group 1 are group 1 because they have 1 electron in the outer energy level. And when they bond, they're going to react. They're going to lose that 1 electron. And so they would always have a +1 ionic charge. Group 2 always lose 2 electrons, so they would have a +2 ionic charge. Anything in group 3 would have a +3 charge. Group 4 we don't consider when we're talking about ionic formulae. Don't worry about it. Group 5 is trying to gain 3 electrons. It has 5 electrons in its outer energy level. It needs 3 more to make it stable. So the magic number there being 8. And therefore it would gain 3 negative electrons. Its ionic charge would always be -3. Group 6's ionic charge would always be -2. And group 7 would always be -1. Therefore, if I asked you, for example, what would the ionic charge be of oxygen, you would find oxygen in group 6, and so it would be O-2. Whereas if I said to you, what's the ionic charge on potassium, that is K, you find potassium, K, in group 1, so it would be K +1. It's my suggestion that when you get into any exam, you scribble this down on your periodic table that you're given, and then you don't have to think about it or remember it, you've got it in front of you. Okay, so let's try a little quiz. I appreciate the periodic table is quite small for you there. However, try your best, or if you've got another periodic table, absolutely use that instead. So pause the video each time, try to find your correct answer and see if you get it right. So first of all then, what's the ionic symbol for lithium? And the answer would be Li+1 because lithium is in group 1. Okay, pause the video. What's the ionic symbol of chlorine? Chlorine is going to be -1. It's in group 7. What's the ionic symbol for oxygen? Oxygen is going to be -2. It's the top of group 6. Group 6 are always -2. What's the ionic symbol of potassium? Potassium is going to be +1. It's in group 1. And what's the ionic symbol of magnesium? Magnesium is going to be Mg+2 because it's in group 2. So now we know how to find out what the ionic charge of an element is going to be. We need to figure out what happens when we put these ions together. Now you've got an example of magnesium and chlorine. Magnesium with a +2 charge wants to lose 2 electrons. Chlorine only wants to gain 1 electron, and so these two are not going to work well together. Something else needs to happen. These numbers need to be the same. They need to end up with a neutral charge. And the way to do that in this example is by adding another chlorine. So now we have a +2 and we also have -2 because we have 2 chlorines. So the formula for magnesium chloride would be MgCl2. I need 2 chlorines to balance out that 1 magnesium. We're going to look at the drop and swap method in a minute, but let's have a look at this first version first. Okay, so what do we think here? If you want to have a go, pause the video. What's the formula, the ionic formula for lithium chloride going to be? Well, hopefully you would recognise that lithium is going to give that 1 electron to chlorine and both would be stable. My numbers add up. I've got a +1 and a -1, and so I'm happy that I need 1 lithium and 1 chlorine, and the formula, or the ionic formula for lithium chloride would be LiCl. What about these two here? Well, magnesium wants to lose 2 electrons. Oxygen wants to gain 2 electrons. So actually these two work really well together. 1 magnesium will actually balance out 1 oxygen. And therefore the ionic formula for magnesium oxide is simply MgO, 1 of each. Okay, what about this one here? Well, lithium only wants to lose 1 electron, and it will happily give that to oxygen. Lithium is stable, but the oxygen isn't. It needs another lithium, also giving its electron, to then complete the outer shell. Therefore, for this example, I would need 2 lithiums balancing 1 oxygen, and the formula will be Li2O. What about this one? Okay, for this one, magnesium wants to lose 2 electrons, but chlorine only wants 1. It can't take 2, it would make it unstable. So it's going to take 1 electron. So chlorine is stable, but magnesium is still wanting to get rid of that 2nd electron. And therefore, we could have another chlorine here taking that electron also. So for 1 magnesium, I could actually stabilize 2 chlorine atoms. And therefore the formula for a magnesium chloride would be MgCl2. Okay, I'm going to teach you the drop and swap method. I don't really like it because it doesn't help you understand why things are happening, but as far as getting the answer correct, this works every time. So you're going to drop the letters down. So I've got Mg2+ and I've got Cl-1. I'm going to drop the letters down, Mg and Cl. And then I'm going to swap the numbers. So Mg becomes Mg1 and Cl becomes Cl2. Notice they are in a different position. We don't have the plus or the minus because they've been cancelled out. So the formula for magnesium chloride would be Mg1Cl2. Now normally we don't write the 1, so you would simply write MgCl2. And this works every time. Okay, pause the video and have a go at these formulae. Okay, so here are the answers. If you did the swap and drop method, absolutely fine. If you did the other method, absolutely great. But those are the answers there. If you're struggling with that, then rewind the video and have another look. Okay, so let's look at some exam questions. This one gives you a table of some common ions. And notice we've got some, if I can show you here, we've got some polyatomic ions, or just that one there. That means that it acts as one thing, N, which is nitrogen, O, which is oxygen, but it acts as a single substance with a minus charge. Okay, so how would we approach this question? It says, write the formula of aluminium oxide. I would suggest you pause the video and have a go, and you'll soon know where you've gone right or wrong. This is how I would do it. So I need aluminium. I'm going to find aluminium on my table. It's here. Let's just jot that down. And I need oxide, which is here. Okay, so let's jot that down. I'm going to do my drop and swap method. So that's going to take the 2 and that's going to take the 3. And so my formula will be Al2O3, and that is the correct answer. Okay, so this question it's similar but a little bit different. So it says a teacher wrote the formula for magnesium nitrate as MgNO3. A student says the formula is incorrect. Who is right? Explain your answer. So first of all, we've got to figure out who's right, and then we've got to give a reason why. Now, for me, the best way to do this is to ignore the answer that it gives you, the MgNO3, and work out what you think the answer is first before you confuse yourself. So we need to know the formula for magnesium nitrate. So here's magnesium. So let's just jot that down. And I need nitrate, which is here. That's that polyatomic ion there. Now, if I use the swap and drop method, sorry, the drop and swap method, MgNO3, okay, if I swap that, that's going to be a 1. I'm going to leave that blank because I don't need a number there. I could write 1 in, doesn't matter, you soon get the marks. And then this one here. Now, the problem is if I put a 2 next to that 3, it's going to read 1 nitrogen and 32 oxygen. That's not right, is it? This polyatomic ion is acting as one thing. And so the whole thing, NO3, I need 2 of them. I'm going to put brackets around it, the 2. So the question was, who's right? Well, is the teacher right? Well, the teacher's not right. The student is correct. The formula should be Mg brackets NO3 2. Okay, and that will be the correct answer. Okay, so for this one again, let's have a look. This question is about compounds of magnesium. Magnesium hydroxide contains magnesium ions, so we've got Mg2+ there. It's not asking us to find it out. And hydroxide ions, OH-. So again, that's polyatomic. It's got the O and the H together, which could mean we're using a bracket. Write the formula of magnesium hydroxide. So I've got magnesium, Mg2+. I've got the hydroxide, which is OH-. Okay, I'm going to drop those letters down. I'm going to do the swap, so it becomes Mg, well, it's just 1, so I'm going to leave that blank. And then OH is going to be 2, but I've got to keep them together, so I'm putting it in brackets. There we go. And the formula for magnesium hydroxide then is MgOH2. Okay, guys, that is the end of the lesson. I hope it's been helpful.